But it was mm, oh, okay. Mhm. It was quite difficult. It was quite a difficult project. Okay, so let's start a little bit with the members. Okay, I am Roberto Chavez, and my colleagues Ariel and Habib. Okay, so what is the thing? A little bit about Telecom. The company works with different companies. It brings them like very high quality products. Basically, what the company does is to develop, in our understanding, they develop different applications, different systems that are of use for their clients. So they basically working with different companies developing different systems. And the thing is that something happens about what they do. Since they develop different applications, sometimes they have APIs that work in common with these systems, with these applications. And here we can see a general diagram of how their systems work. So, for example, there is a given system A, yes, there is another system B and C, and they are interacting with APIs, with similar APIs, with APIs. So, a given API, they are fetching information from a given API. So, their systems work, interacting with each other. And the thing about this structure is that they want to see how is that these systems interact with each other. They want to have a general view of how this interaction happens, how functionalities are shared, and we can how is that they do it. Currently, the company is using this tool, which is like a modeling, architecture modeling tool that they can use in order to draw diagrams. The tool that they're using is Archimate, where what they can do. Okay, so they can write like the components of an application. They can also write how the components interact with each other, what associations they have, and what dependencies they have, yes, with regards to other applications, to other APIs, what I was talking about in this slide. So what they do is they draw these diagrams, they do it manually. So when they, for example, have an application and they update the application, or they add a new feature into an application, then they have to also manually update the diagrams that are written here. How is that? What format do these diagrams follow? Well, they follow the model, which is called, well, in general, they follow model. Or their models resemble the C4 diagram model. The C4 diagram model is a model that basically contains 4 levels of information, 4 levels of detail. As you can see, the first level is the context, which is the highest level, yes, the highest level of information that you can get. And then you have in the second stage, you have the container, well, the components that in the third space, in the third level, and finally, like code, yes, like it can be like what a given component does, for example. Then what a given component does. So the specification for a given component, that's the last layer. In containers, we can find, for example, the APIs, yes, that they are working with. So this is in overall what's happening with Ross Telecom. So they develop applications. They use APIs in common, and they want to see a general overview of how these applications interact with each other. And in order to do this, they do a manual work. They use this Archimate. Yes, generally they use this Archimate to do that, like to draw the diagrams and to be able to see how they work with each other. So what was the task? The task was actually to find a way to automate this without necessarily drawing it by hand. And they suggested, well, our client, Konstantin, well, he a very kind person. He suggested that probably we could look into the functionalities of GitLab and Kubernetes, which are the tools they are mostly working with in their projects, using continuous integration and continuous deployment. The objective was for them to find a way to, as I said, automatically generate these diagrams. So we had an idea. Well, we were trying to find a way in which, for example, we could fetch some metadata from GitLab or some information from GitLab or from Kubernetes, and send it as a as a file of metadata to Archimate, and generate a diagram automatically. So that was the focus of the task. And well, what happened is that I would like to say at this point of the presentation that for our team, it was not possible. Well, we couldn't really find a satisfactory solution for our customer. We understood the requirement. We tried to find what the client requested, but in our case we couldn't do it. So it's that's of course well, it's very sad for us personally as a team, and we hope that the next team can. We know there's another team that is working on this case. We hope that they will present something more useful for the client. However, we wouldn't like to leave this hackathon with empty hands. We would like to offer an alternative that the company might want to look at, like in the future. Probably they want to increase. They want to start like probably with different technologies. If it's tedious to draw like manually a diagram to see how the systems work with each other, probably they might want to use this tool, which is called Structures. And what is this tool? This is a tool that draws diagrams, just like the C4 model diagrams, but by means of writing code or by means of writing text. So it works in two ways. The first way, you can draw diagrams as in text, as I am showing in this image. It's a way in which you can organize your systems, the elements that are there, the components. And from this script, you can generate a diagram, a C4 model diagram. Another way that this tool operates, it operates by writing code. And if I will show it in the next slide. So it might turn out to be, it probably might turn out to be for some people, for some professionals, to be able to organize their ideas better by coding in a more structured way than just drawing in a drawing tool like Archimate. So this is another variant that they could utilize. So they could write the code. In this case, the example is shown in Java, but they can also write their diagrams. They can write them in Python, for example, and they can get their diagrams out of this code. And when they need to update the diagrams, they just need to write the code for it. How this application works? You can. Now I'm going to, okay, so that's it. I'm going to quickly show about this tool, just because it turned out to be interesting for us. Okay, so there's a series of steps how to use them, but for example, in this case, you can see it's a very small demo of how to write a diagram with text. And for example, I am going just to on the left side of my screen, you can see like the text for to draw a diagram. And on the right side is the diagram already drawn. I'm going to quickly, like for example, here add a new user. By the way, I would like to say that the understanding of how to write these scripts actually are given in tutorials. Like for example, to write a script in a domain-specific language, DSL. There is a tutorial for this tool that is, well, now I'm not being able to show it, but there is a tutorial in GitHub, very detailed. Okay, so I'm just going to quickly use 3, for example, and then I'm just going to try to. Okay. So what's going to happen now is there is going to be just another more user here in the diagram on the right. Oh, there's a mistake. One moment, it should be here. Okay. Okay, again. Well. Okay, and there's one more user in there in the diagram. So this tool brings the possibility of drawing diagrams. So that's something that it could be interesting for the company to look at in the future. As to the rest, that's it. And now, thank you very much for your attention.
Any questions from the jury?
I think I have some just comments. So yeah, thank you very much for your work. It's very useful to us to see some different perspectives on this case. So yeah, we can potentially choose this supervisor tool to create this diagram out of some kind of code. But here are some drawbacks. First of all, these codes for diagram needed to be created manually, so don't have any options to build it out of some ICT process or maybe some code of application themselves. And second one, I guess, the most crucial, most critical, is that the supervisor is provided as a software service. So we need to buy some kind of subscription, and these diagrams will be shown by this supervisor service. So our sensitive data related to our price architecture will be stored in supervisor server, which is, I guess, is possible in Rust. So this is, I guess, this is the main restrictions that we have. That's why this solution is very interesting, but maybe not so suitable for us. Anyway, thank you very much. It was very.
Okay. Okay.
Any more questions from jury? Okay, then thank you very much, Roberto. Thank the team. To the next team.
Okay, thank you. Thank you.
Group A MSD. So yes, please.
We expected that here work.
You can. Yes, we can choose a presentation from this.
Yeah, let's do that. We submitted and we did not expect.
Yes, we do that.
Second. pen tool to switch the
Yeah,
slide.
is there a pen to switch? Slides?
Here is the pen.
Okay, that's the-
Switch the-
It would be nice if you had.
Yeah, let's do the Zoom.
Zoom, please. Take your time. Take your time. We have
Thank
a couple of minutes. No problem.
Hello, everyone. So we have a super exciting topic, microservices, otherwise known as death by million cuts, small cuts. When you have one service, that's fine, works. You add another one, you add a third one. When you have 1,000 services, it becomes really impossible to manage. And if you are a big corporation like Rostelecom, then you really have to have a system to manage all those microservices. Next slide. So what would you do? You would need some kind of diagram to have overall view of how things are working. You would need to keep track of all the services, and you need to know how those services are connected. So what's going on in your system as a whole, not just one part of software, but everything. Next slide. So the system as it is, you've already seen this picture, little deja vu here. Rostelecom is using a way to represent, using Archie, represent their services, how they connect. Next slide. So who's using the system? Project managers, system analysts, system architects, people who need to make decisions, who need to understand the system, how it works. We have Konstantin, who's head of system analysis. And thank you very much for helping us with this project. And he's the champion to improve this system. He's interested in making that system better with what they currently have. Next slide. So why are they using this system? They have microservices, not only microservices, probably larger services, for example, database, maybe something else like Redis. When you onboard new people, you need to show them what's going on in your company, different pieces. So for onboarding, when you talk to your customers, you want to tell them how reliable your service is. Those things called SLA, service level agreements. You're saying that your service is going to be up 99% of the time, but how do you calculate it? You have to find all the dependencies. The service depends on A, B, C, D. You combine those, and then you can estimate what your SLA is. So you can at least not lie to the customer because that costs money if your service is down. Then component dependency. If you have something, you have a service, and it does not rely on anything, like nobody's using it, you want to know that, or you have a service that thousands of other services using. You want to know that. Then resource allocation. Maybe there's a very important service and developers maybe once a year look at it, but maybe you need to invest more time into it. Reusability. Do you create another service or do you reuse existing one? It's actually one thing about microservices, they multiply. If you have 10 services, you're like, okay, do I need another one? Maybe, but if you have 1,000 services, next week you look at them, it's 50,000. And then make right strategic decisions. Maybe you don't have expertise in certain areas anymore in your company, and you want to move from schemaless database to something else. Next slide. So the current stack that Rostelecom is using is fairly standard. There are Docker containers, there's a CI/CD pipeline. They use a flavor of Kubernetes OpenShift. They're using monitoring with Prometheus and the tool that they do the drawing architecture. Next slide. What are the pain points? As was mentioned, they do it manually. So you have to draw that diagram every time something changes, you have to update it. Developers don't have a standard way to report changes. If you're a developer and you develop a new service, how do you tell the company about it? You're like, okay, I deployed it, it's working, let's go use it. But maybe you need to report what are the dependencies, what the other things may rely on that service or how it can crash. The models get inaccurate over time, service is working, some features are added. Your model, if it's done manually, it goes out of date, so you cannot kind of rely on that. So there are no standards for information to be reported, and there's no way to validate. Even if you reported something saying, my service depends on some kind of SQL database, Redis, RabbitMQ, something else. There's no validation of that stuff. Next slide. Requirements. What we gathered from Rostelecom, the most important thing is that the solution has to be in-house. You cannot use software as a service because there are lots of customers, sensitive data, sensitive solutions. So you can't use software as a service, no cloud solutions. It has to be frictionless. So you cannot come and say, here I have this giant tool, very complicated. Please learn it, take a year, make all developers learn it, and we'll integrate. That's not gonna work. There's already system in place. The new solution has to work well with the new system. One important part we gathered from requirements is that, let's say you have a model of your system, and it shows some kind of service. And it's really a problem if this service does not exist. It's better if, in reality, you have some service, but your model does not represent it. It's not on your model, it's okay. But if this service in the model, but not in reality, that's a problem. So avoid ghost services. That was a key point. Follow existing deployment practices. They invested a lot in their CI pipeline, in their methodology. So this system has to integrate into that. Next slide. So what we have as a system right now, we're all here about diagrams. So we prepared a couple for you. So there is a repository. The developer creates new repository, it says a new service. You have CI/CD running tests. If they fail, go back. Then you have a deployment. And here you have a person who looks retroactively at what's been done and then adds this to a metadata aggregator. They use Archie and then shows the representation, the graphical representation, how it looks. They have monitoring service as well. They have like testing. So all that system is in place, but that's where the cumbersome part comes, because that's a person, and looking back retroactively is hard because you don't know what happened, what other services were added or deleted or changed. And so we thought of this and we propose a different approach. We try to hit all the requirements and all the points. Here's a general overview. Konstantin proposed one solution. So in the repository, you have a special folder or special YAML file where developers can specify who's in charge of this service, so what are the requirements for this service, and other data. So that part where you specify requirements, it happens not at the end, but at the beginning, right? Where you commit the code. Then it goes through your CI/CD pipeline. After your tests pass, we have a special validating schema that looks at that metadata that you included. And here we have requirements. Like if your service doesn't have a name, fail. If your service doesn't have a description, fail. If you did not specify something important, like your service type is this, and you didn't specify how it can crash, how often you expect it crashing, maybe some other data, it will be a fail. And then once it passes this validation, it deploys as usual. Here we added a couple extra steps. So at this point, it would be okay. It would work, we can verify, but we still don't know if this service really exists. Maybe something happened, it worked for a little bit and it's not working anymore, but it's still represented in our metadata information. It would be nice to kind of show it in red, for example, say this is working or it's not working, or it's under heavy load. It uses a lot of resources. So that information would be cool to have. So we added this extra service. We call it Watchdog. That interacts with metadata aggregator. Once you deployed everything, this Watchdog, let's say every night, looks at those metadata tags, connects with monitoring service, and enriches the metadata. So then in the morning, you have a fresh graphical representation of your entire system. So here we asked specifically for monitoring services capability. You can query for data, like what's going on, how much certain resources are used, what kind of resources are there. We can get that information. So there are a couple points here. One is, how do we represent this metadata about your service? There is a tool called, could you go to Pivio? And let's, I forgot about that slide. Let's go back to the what kind of metadata, like dependencies, description. We can limit it to number of lines. Very important part about your microservice is who's responsible for it. So if something crashes, who do you ask? Who do you go to and say, come on, help me out here? Probably link to documentation. So this is just an example of what kind of metadata can be there. And as I mentioned, we can introduce that at the point when you commit your code into repository, and we can check it during existing CI/CD pipeline. So one of the tools proposed was Pivio. it fits that architecture fairly well. It has this aggregator service. It has a client. It has the ability to extend, so we can write that watchdog in that in PVO. The pros is like it's open source, so it can be deployed on premise. It integrates with the repository. It's extendable, as I mentioned. Cons, it's very alpha project. Like we were able to run it a bit. 3 components worked, 1 didn't. Right off the bat. So no support. Who knows? Maybe there are 4 people who are doing it, and maybe they're like, we're done. We don't like it anymore. So that's a con. Next slide. So in the other point, once you get all that metadata through the pipeline, you have this database of what's going on in your system. And if you look at it, that's what you will see. There's all the services they connected, what's going on there. It's really hard. The other problem that we need to solve for Rostelecom is how to visualize the data. There's several ways to do that. And that component is separate from this main pipeline. So we got the data in about the microservices, and now this is analysis tool. So you can write your custom representation. You can use Archie as is used in Rostelecom currently. There are a couple other things that we looked at. There's plan UML, the C4 model, and then out of this spaghetti code, you can, for example, with C4 model, you can, next slide, you can get more meaningful data. That representation tool was also suggested by Konstantin. You have different layers of context, like level 1, level 2, level 3, 4. That's why C4. So you have overall view of your architecture, and you can zoom in into different components. So it's one way to deal with that spaghetti thing. So you have clusters of things, how it works. So this is a general approach how this microservice nightmare can be addressed. There are a couple points. There's several tools that can be used, but we believe with that, if that approach is used, we can cover all the bases in terms of that the data should be there, that data is validated, and that we know the current state of the system pretty much daily. Any questions?
Anything from Yuri?
I guess again, not so much a questions, but kind of comments. Yeah, thank you very much for the work. It's very helpful, and I think the ways of dealing with this case you suggested very coherent to the work that we use now. So I think we can describe these solutions that I mentioned, and I think they can really help us in this case. So if you're interested in continue work in this case, please let me know.
Yeah, it's actually a very interesting case because I've seen that problem in other companies. That's not unique for Rostelecom, and it was solved kind of like, we have this pain, let's do something about it. Something, anything, just like have a catalog, so at least I can search my microservices. But I haven't seen any like deep approach to solving this problem, and it's a problem for many corporations. Like, I don't know how does Google do it. Like, they probably have this problem as well, and they have the solution for it, I guess. Oh yeah, they thought of Kubernetes. That's the solution for the microservice nightmare. Any other questions?
Okay, any other questions, Yuri? Otherwise, thank you very much for the invitation.
Thank you.
Yeah, so we'll have some time for lastly, I guess Dawlet wanted to start a bit later, so you may set up, guys. With banana solution set up, you can set up. Go banana. So you have time to set up. So sure, there's 5 minutes, but probably more. I will check with Dawlet.
Is that clear? It's not clear.
He said, I understood. We will let this.
Yeah, yeah. So what we need to write is action.
So guys, you can go online and just Dawlet is almost ready.
Because they have both.
Yeah.
Yeah. Yeah. We studied this case better than you studied. We just fight from him.
Okay, so guys, you can start.
Go boys, go.
Go bananas.
Go bananas. Go boys. Honestly, should we get? One person should be there.
Okay, we can
Where-
start.
Yes,
Oh,
we have
that's
customer for allowed play. It's not Dawlet, so it's online. But Lera would actually present allowed play. And, she's the real employee of allowed play, not like Dawlet. Really for allowed play.
Okay. So let's start then. Hello, our team's name is Banana Solutions, as you already know. And we decided to take on Loud Play's case for this hackathon. So Loud Play is dealing with cloud gaming, and cloud gaming is basically when video game runs on a server side and you as user send controls from your machine and you get a response as a video and audio feedback of your controls from the server back to your machine. So we propose the next outline. First, we go through introduction. Then we state our assumptions of users of Loud Play. Then we discuss case concerns for our solution. Then we show some examples of the problem. And then we go to solution approaches. We decided to take 3 methodologies of image correction algorithms in painting, interpolation, and super resolution. Then we conclude our presentation and leave some place for questions. So let's go. Yes, cloud play deals with cloud gaming, and therefore it heavily relies on internet connection quality. So, however, if the internet is not so good, you will get some artifacts, some corrupted images in video stream, and you will get latency between your control inputs and feedback as video. So to address this, we have research approaches that use ML models to fix these problems. So as we discussed with Dowlet, most of cloud place users have low internet bandwidth, and sometimes they even use mobile internet. So, and also they don't have very powerful hardware, otherwise why do we need this service, right? So, and here are examples of the problems. So the first, low internet bandwidth cause corrupted images and very unpleasant to eye, as you can see here. And the video here shows the latency between users' input and the feedback. So basically, let's watch. See, user inputs, but we get delayed sort of feedback. So yeah, here are two main problems. So our case concerns for our solution is that image correction algorithm should be able to run in real time on user's machine, which is not very powerful. Image correction algorithm should produce significant improvements to user experience, for example, like erase this latency lags and improve the quality of video stream. And also algorithm, as Dowlet said, should be relatively easy to implement and within constraints of Cloudflare. So yeah, the solution approaches, as I already said, are in painting, interpolation, and super resolution. They're based on machine learning, and we decided to go with this because they're relatively popular in research society and among practitioners as well. So yeah, let's start with in painting.
Okay. In painting is next slide, please. In painting is the first thing that comes to our mind because it's quite strange. We use in painting for fixing the corrupted frames inside the videos. So for example, we have such kind of randomly generated masks applied on the frames, trying to simulate that these frames is corrupted. And we use some algorithms to utilize those neighborhood frames to fix it. Looks like perfect. Next slide. Yeah. So we picked up some state-of-art methods with this kind of knowledge graph tools. They are basically these 2 years works, but not like the latest because for us it's still a little bit difficult to identify the latest work if it's qualified or not. So we just select them based on the number of citations and the reference that's used. Next slide. So after we picked up these papers, we dipped into the experiment side sections of the papers, trying to figure out what kind of computing power it needs, the input resolutions used for experiment, and how much frames it can produce or how much frames it can fix per second. because these are, I think, our customers' concerns. After this comparison, actually, it's quite difficult because those experiments, they are run on different hardwares and data sets are different. So we're just trying to figure out if this methodology is somehow feasible on a normal middle end laptop, or the runtime speed is acceptable. Unfortunately, finally, we can make a conclusion that in current stage, there's no such kind of impending method can be directly applied to our case, because they are heavily depends on the computing power. A lot of high-end GPUs are used for accelerating the inference speed. And also, besides this computing power requirement issue, there's also some other limitations. For impending, we need to tell the model which part of the frames need to be restored. So first, we need to somehow detect the corrupted areas. Then we can only able to apply this method. Possible solutions to these issues is something like tackling the whole frames, divided them into small rectangles. And when we have had such kind of interview with our customers, they said they have ways to detect frame is corrupted or not on real time. So I think if we divided them into small rectangles, we still have the capability to detect if each subframe is corrupted. Then we mask it automatically, then apply this method. And also we can try to apply some techniques, try to compress our model to speed up the inference speed, something like that. And also nowadays we have to mention that on mobile phones, because we have mobile clients as a product, just some clients, they use mobile phone to use loud play service. Nowadays, these mobile phones, they have special hardwares for accelerating ML models. So, and it's somehow comparable to some middle-end computer GPUs as a reference from reviews from Microsoft Research. And so we can try to somehow fit our models into this kind of special accelerators to make it faster. And also we may try to downscale the input of the original videos, and then try to upscale it by some super resolution algorithms after the model generated the output. So we just need efficient such kind of super resolution algorithm, which will we talk about it later. Yeah. So these are, yeah. Next slide, please.
Yeah. When we were experimenting with cloud gaming thing, we saw that if you lower the frame rate, it becomes more clear and it becomes more stable. So we researched about this, how we can get low frame rates, but we can increase this frame rate. So we found out that there's a method interpolation for improving frame rates and also enhancing visual quality. What interpolation does? Interpolation synthesizing non-existent frames and
between two original input frames and creating a new frame from these frames. Interpolation has many applications, also in video gaming and also in video streaming. Some companies use it as provide good user experience by increasing the frame rates. And also Facebook used it for their VR Oculus for getting more FPS in the low-end devices. Okay. Then we searched about the methods which we can use. We found 3 algorithms about interpolation, Rife, Kane, and extreme video frame interpolation. These ones are using deep neural networks for getting the for creating a new frame and getting the frame interpolation. And extreme video frame interpolation is good for 4K and 1000 FPS. So it is good for high quality videos. Also, we found a benchmark for these 2 algorithms. Benchmark as done on the NVIDIA Titan X GPU, and it is at the data set, it is using Middlebury 2014. What Middlebury 2014 is a data set which is most commonly used in the VFI, like for video frame interpolation, and it is consists of 480p pictures. As we can see from this benchmark runtime, it is Rife is better than the Kane, and also when you are comparing the overall quality, it's also Rife is leader in this part. Next. Insights. Interpolation gives us more FPS, and because we have more FPS, we will have smooth video. We found out that it will be less load on the server side, as we will send less FPS from the server side, and it will directly convert it to the more FPS, so less load on the server side. And also because there's a corrupted frames when there's a transmission between the server and client, we are proposing that with interpolation, corrupted frames can be regenerated with interpolation. Yeah. Disadvantages. We found out that it requires heavy computing power when you are using high resolution input, and in some cases it can create visual artifacts such as here because it looks like glitch. It can decrease the user experience.
Next, please. So while researching, we came across a wonderful methodology. It is known as super resolution. Actually, in our both of previous technologies or methodologies, we have only one bottleneck. That was the resolution. When we increase the resolution, we need more computational power. So we came across super resolution. Super resolution, as its name tells, that super resolution is going to give you better resolution. And I will tell you how we are going to apply it in cloud plays scenario. So what are the applications? Super resolution was invented for medical images to increase the medical imaging output to look better what inside your body. And it is also used in surveillance, but nowadays super resolution has been utilized for smart TVs to give us better videos or HD results. As you can see the effect of super resolution in this GIF, that we are increasing the resolution. Can you go to the next slide, please? So while researching about super resolution, we came across different algorithms. And these are the three best algorithms we found, and we think that we can apply those for loud play scenario. First one is anchor-based mobile net. It is a net. It is an algorithm which is specially designed for mobiles. As Dolat already stated in his presentation, that they are giving services not only to computers, they are giving it to cell phones as well. So we have to think about cell phone. So this is an algorithm which can give us 27 frames per second, and it can increase the resolution of video 3 times and with the quality of 1080p. Then there is another algorithm which is going to give us 4K videos, and it requires some GPU. Also, its speed or its inference time is better than previous algorithm. Then we found another real-time single image and video resolution efficient nets of pixel. So this thing is, according to the authors, this is the best thing they can ever come up with. This paper came out in 2016. It gives us 34 FPS rate. Microsoft is also utilizing this paper, and this paper can increase the resolution 3 times for achieving 1080p quality. Can you go to the next slide, please? So our insights, we came across that resolution. Yeah, we are going to get high resolution. High resolution is connected to our concern, which is user experience and good performance. How to do it? We can use super resolution. We need lightweight models, as we're going to use it. As already Dolat mentioned, that those models should not consume a lot of space on client side. So we need a lightweight model for super resolution. So Loudplay needs to think about what kind of model they need to use. Also, training, like we can generalize a model which can be applied to different kind of games. Well, I'm a data scientist, so if you generalize it, you will not get good quality on all of the games. So we went through Microsoft research. They're using Level Up paper. They have stated that if you use specific model for a specific game, then it is going to give you good performance. And before using this model, Loudplay needs to think that they have to think about inference time and computation. As we increase the inference, we have to increase the computational cost, which is not what Loudplay is looking into. So this is how, can you go to the next slide? This is how super resolution works. So usually when cloud is sending frames, they send frame at high resolution. And when there is bad internet, the frame get lost and it doesn't arrive to the client. When it doesn't arrive to the client like me, I will think of breaking my laptop screen. So how can we save my laptop screen? I'm giving you a solution. So we will send low resolution frames. Can you press button? And then we will apply a lightweight super resolution model to increase the frame size. And when we'll have a good frame, then I'll be happy and this problem will be solved. Can go to the next slide. So we came up with a methodology which is not like scope of this presentation, but it might be helpful to Loudplay, that we will use 2 models instead of using specific super resolution model. So a model, any machine learning model, which is specifically trained to decrease the resolution of the frame. And on the user end, it will increase the resolution of the frame. So what's so beautiful in it, so catching in this methodology, it's that when we decrease the resolution of frame by knowing that what approach we're using, we can regenerate the frame because we already know what methodologies or what kind of steps we have taken to decrease the frame. So it's first we'll decrease it, then we'll increase it. Usually it happens that when the frame is at low rate, we don't know what kind of computational theories or what kind of methodologies are applied on it. But in this scenario, we did it our own self, so we know how to solve it. Can you go to next slide? Next slide, please. So, no previous one. So our conclusion. So we try to solve the case concerns of Loudplay. We came up with methodologies which are going to perform us, which are going to give us good FPS, good user experience, and good user experience on cell phones as well, better resolution and better FPS. We have identified some algorithms, best algorithms that are going to be applied. We benchmark some of the algorithms. You can take it from us later, and we can propose a methodology which can potentially outperform the previous methodology. Also, these three methodologies, these can be used as a pipeline in a lightweight scenario so that you can apply all of these in painting, interpolation, and super resolution. And we go to the next slide. And that's it. If you have any questions, you're welcome to ask. Stage by two, banana solution.
A lot of questions.
A lot.
Not a lot, but I started. First of all, thank you for your presentation. And I want to see first slide of the page also of my company.
Can you go to the first slide?
First slide, yes, with logo and something. Yeah, first slide. And
Which one? Home button. Sorry.
no,
No, it's
Yes.
this one.
yes, with our logo.
We'll send you the screenshot.
Yeah.
With us?
No.
Of
Of course, with you
Smile,
guys.
smile.
No. Yes.
It seems that to have numbers on slides is a good idea.
Yes. And then can you send me this presentation?
Sure, we'll follow.
And you have you tried to play in our launch?
Yes. Yeah.
Did you got the app on your phone? You know
Yes.
that our play has on
Yes,
mobile.
we have
Yeah.
tested those, yes.
Thank you for this because it's very important.
Okay.
I wanted to hear something about mobile phones and your solution is very good, but it's not lightweight solutions. It's
Oh,
very
okay.
hard to apply.
Yeah.
Yeah, my question and what the best solution what's the best in your opinion?
The best solution is relating to super resolution. Actually, I think I've talked about some models could be deployed on the mobile devices. It's quantized, so it can speed up utilizing the accelerator on Android device.
Quantization, it will increase the inference rate and it will decrease the size of the model.
Yeah, it can, the original resolution of input video can be 480p, and it can be scaled up to full HD on a mobile phone real time.
Yes, this technique is very like close to Samsung in TV. They got like, and you think that installation is very bad? Yes.
No, you
No.
said that.
It's not
Why not?
it's not practice because it needs have a computing power, and also if we only slightly increase the frame a little bit, it doesn't improve the user's experience significantly. For example, we have 30 frames per second, but our algorithm running on a low-end devices, perhaps it can only produces 1 frame per second. It doesn't make significant difference.
Okay, what I want to also see this comparison with our algorithm. With, I didn't see any slides about it, and I didn't see any slides about algorithm in different companies. I heard that you told that it was in Facebook something and something in
Yes,
another company, but my expectation was to see more these things in different companies.
But you see, from the papers that we researched, it mostly was either about like abstract video restoration or about video streaming. So, but for example, there's Level Up paper that we mentioned already. So they deal with streaming, and they don't mind latency of 1-2 seconds. But in cloud gaming, it's very important that they should know such latency.
Yes.
So we didn't actually find any papers about what your competitors, so to say, do.
Of course, because yeah, video streaming is not supposed and what you can say about upscaling?
Upscaling. It's you're talking about super resolution.
Yes.
Super resolution, like he also mentioned when you asked your one
Can
question.
you show me the table separation?
Version.
Yeah, actually, there is a method which was adopted by Microsoft, which name is ESPCM. It's proved as efficient enough to scale up the speed of the scale.
For super resolution.
Super.
Yeah, for super resolution. My apologies that we didn't list them very detailed properties because the time is limited. Well, Avice can.
Yeah.
a little bit
So this paper, the last one, using efficient net. This is adopted by Microsoft. They're using this in their problem, and they scale the videos 3 times to achieve 1080 quality, and they're using K2GPU, single K2GPU, which is not that much. And also they state that they can use it's heavyweight. Well, they use a light version in level of paper that you can use specific lightweight version of such kind of algorithm to deploy in your problems, to deploy your for your problem.
Yes, and if you have some interest in the mobile applications on the mobile ends, you may look into this series of papers. They basically just run this algorithm on a Snapdragon 8A20. And this year they have a challenge called Mobile AI Challenge. They have a series of paper about applying these lightweight mobiles on a mobile phone. They got a relatively good result. Yeah.
Okay, thank you guys. It's really good to work.
Yeah, and also you can find the implementations.
Yeah,
Yeah.
all of these have implementation. Like it was first concern of Dolan. His name is Dolan. Yeah. So he said that we don't need to look into Reed Solomon. We have to focus on machine learning. So we are focused on machine learning.
Yeah.
That's,
So I think we have it.
yeah.
Yes, but it's very good work. Thank you.
Thank you.
Yeah, guys, actually, I answered all my questions. Again, great presentation. Thank you. Great work.
And our last team.
No.
So hello everyone. We are group E minus. My name is Elizaveta, and this is Roman, Denis, Aida, and Yaroslav. Today we're going to present the solution of Cloudplay case. And first of all, Cloudplay context. Cloudplay is a cloud gaming company, and the team is quite talented, but not that experienced in DS area. And so the solution for this problem is supposed to be not that complicated. The problem itself is bad internet connection, because it's a bottleneck for cloud gaming. And about some technical information, it uses UDP or TCP protocols with Reed-Solomon algorithm. Reed-Solomon is quite old algorithm, but quite reliable for detecting damaging images. And their desire is to have some ML approach for this problem. Also, they think that that approach might help them in marketing area. So the task was to research and compare different error correcting and image completing algorithms, basically based on machine learning approach. And requirements for the solution is very simple. It should be quite speed because it's very crucial point, and minimum amount of frames per second is 30. The maximum ideal is 60. And also image performance is very important because this is the main problem, that images are not in good quality. And the other point is the model on client server is supposed to be lightweight because they don't always use quite stable internet connection, and sometimes they might use mobile phones to play games. So lightweight model is very crucial, essential. And yes, this task is preliminary research. So our methodology was to find some papers about this topic. And here is some example of searching requests. And it was very important to have video error correction because there is a lot of cases of image correction, but image correction is something different from video correction. And compare it with the state of the art and in terms of machine learning.
Yeah, so there are actually our results, 3 papers. We considered much more, but there are the best ones. I don't want to waste time on detailed description, just a few words about the first model. It's use unique activation functions that they developed for this task. The second model use only a few images to train, and the last one use a sequence of frames to repair corrupted image. And first and second model use only one frame. We compared them by 3 categories. So how accurate they are in corrupted frames recovery. We compared them by inference speed and how easy are they in development. So as you can see, none of them is ideal. For example, the second model, it's not very accurate because use only one frame. It's not very speed, but it has great GitHub repository. And next slide, please. So we faced with main disadvantages of all these networks, that they are deep, heavy convolutional models. For example, FDNet, the first model from the previous slide, has inference time of 5 milliseconds. And please note that letter F stands for fast. So this inference time on pretty low resolution image and very specific GPU has only this speed. We calculated that for full HD frame, it it requires about 40 milliseconds per one frame. So our main conclusion is that DS approach may be not very appropriate in this task. But if Loudplay would like to use it, we recommend to use some techniques. For example, model knowledge distillation. It's a technique to decrease the model. So next slide. We also did a rapid research. What about the competitors? And unfortunately, we didn't find that they use DL, particularly in recovering tasks. So NVIDIA use one technique for image painting, but it's about not the same, and it requires GPU as well. We suppose that the users of Loudplay don't have good hardware. That's why DS approach is not very appropriate.
So among the papers, we found several papers on adapting streaming. This is not the direct solution to our task to recover the corrupted images, but this is a method to improve the user quality of experience. So this model is trained on the statistics collected from users on how they assess the quality of the stream, and then on the statistics, the model is trained and it predicts the resolution and frame rate that will provide the best quality. So the main disadvantage is that the users will lose their ability to change the settings by themselves.
We found non-machine learning solutions. Video recovery techniques can be classified as redundancy-based techniques. In these techniques, a sender trying to change the packets of data. These techniques is we proposed for these techniques is another protocol. It's one of these protocols called as hybrid error recovery protocol. This is alternative for UDP and TCP. Advantages is number of corrupted pixels is lower. This paper have a pseudocode. Disadvantages is it can bring average delay. Average delay is higher. And another solution in this class is packet securing. So main idea is to divide image into 4x4 blocks and add additional bytes information for these blocks, and receiver trying to restore information by using these additional bits. And another class of recovering video techniques is interpolation. In these techniques, a receiver trying to restore images by frames by using other frames. And after producing interpolated frame, it use additional filtering for this frame. Advantages is it works fast, because from this paper what we found, it used in mobile phones. It doesn't need high computational power. It works well on slow PC and mobile phones. And this paper have pseudocode. Disadvantages, it's bring delays and low quality of image.
So we conducted the research, and according to the results, we do not recommend to use machine learning to solve the task of recovering corrupted images, because they do not satisfy the loud place criteria that the model should be lightweight and work fast. So, however, there is a deep learning application of adapting streaming that also requires GPUs, but it may work on the server side and just compute the resolution and frame rate that will satisfy the user. And our general recommendation is for single player non-action games that we assume non-sensitive to delays. We suggest to apply interpolation method, because interpolation is actually producing a constant delay over a single frame due to the fact that we need the next frame to generate the current frame if it was corrupted. So for other cases, for example, multiplayer action game, we suggest to apply one or both of the non-machine learning approaches that we discussed earlier. So also a little bit about the process. So the research process was straightforward and worked well. Actually, we are 5 data science students, so the research was parallelized, and everybody searched and analyzed papers by themselves, and then put into the discussion the most appropriate ones. Also, it was difficult to compare some papers due to the lack of the important to play metric is speed, because most of the image processing models are oriented on the efficiency and quality, not on the speed. Also, we understand the primitiveness of the process and consider it sufficient for the hackathon.
Okay, now, do you hear me? Do you hear me well?
Yes.
Yeah. Okay, guys, thank you for your presentation. Actually, I'm quite impressed. It's a lot of information that you managed to do. Yeah, I heard that you was quite sad saying that an ML approach is not applicable. Actually, it's kind of good news because you find out this and proved it. And yeah, thank you a lot, both teams, for leaving a lot of links and references to the papers, because it will be huge food for our mind to read them and also to investigate the process further. And also, yeah, I had a warn that both teams will present something like very similar information, but actually, guys, you made it. You made some different views on the problem. The question is, yes, you showed. Can you move to the conclusion slide? I guess it was 11 or something. Yeah. So I see that I see your recommendation, but the question is where to start. Okay, for example, we decided that interpolation is a good approach, or it can be another protocol or packet securing. But what should be our first step?
I think you should analyze what your users play the most. So if this single player games, so you may start from interpolation. Otherwise, you can think of the other two protocols if the users play multiplayer games, and decide to look at the papers and decide which is, I don't know, your priority. So
actually, I can specify according to the statistics, our players mostly play GTA 5, and that's the main games that they play on our platform. Is it considered to single player or multiplayer?
GTA 5, you mean online version?
I don't know. They just run this launcher, and what they do inside, I don't know.
I suppose they play online because it's a pretty old game for a single player. You can look for a paper which we provided. If I'm not mistaken, all of them have pseudocode. Oh, yes. So if you are interested in the algorithm, you can write it on C++.
Okay, yeah, thank you. Actually, no more questions from my side. Lera, maybe you have.
Yes, that's one question about the video technology. See, like their streaming service, and now they also have like the same streaming service, and of course now. Do you look through their papers or something? I know they use machine learning technologies.
I could not find a paper, but on their site I found the mention of streaming, but it is oriented on the streaming of faces on the online conference streaming. And so they like find key points and then generate the images according to the key points of the face. So this is like not applicable to the gaming service, so very difficult to apply.
Yes, but also with video streaming, then maybe it's not helpful. That's okay. It's good results. Thank you very much. And I also want to see this presentation.
Can you finish them all together? Just like
Yes.
Don't forget it.
Yes. Thank you very much.
Thank you. Yeah, so we'll call other people. So 2 minutes for preparation on the final scores.
What about pizza?
Pizza. Stop.
People are eating it.
No. Nobody touches your pizza. Just a second.
Okay. Okay. Right. So. Okay. Okay. Hello, everyone. So thanks for this long day. It was very intense, I believe, for you. Very good presentation. Actually, looking at the scores, very difficult to find the winner. And actually, most of you got actually average score above 4. 5. So 5 was the maximum for an average score before above 5 is actually above 4 is actually quite good, and most of the teams got that. So you worked very good, and jury is very happy with you. So, however, we have to select the winner, and the winner is
the team P plus. P plus will go to winner. Since I have, since I actually have, we have prizes for 2 teams, so I had to select the second team. Okay, and I mean, we have actually on the second place, we have actually quite a lot of teams, and but no, we actually just recently there was actually final vote in suspense, and for some reason the team called P minus got the second place. So guys, congratulations. So I didn't even have to choose draw by randomly, so that's good. Right, so I call here the team P plus, and we have special prizes for you. So I guess you have to choose.
We have 5 people.
You have five, and I believe there is and there is 4M, no 3M, and you have 5, huh? M and L. And so so 3M and 2L. Okay, so so I believe so you know MSD class, everything depends. So we have it depends T-shirt for the winning team. So guys, so congratulations and don't and yeah, we have also winning certificates that I will sign when everybody's got their pizza, and we have 2 for team. But
We can.
Yes. Right, and so then
We can
yeah,
go.
please, thank you guys. Big applause. So P minus team, please come. And we have there 1M and 4. Guys, you're quite a lot. I have contacted for me, huh? Left. Actually, yes, we have. Okay, this will be M. Are you L or M size? M. Great. So we have just enough, and I mean good sizes. Okay. So thank you guys. Good work. And it depends. Also depends for you. And okay. Thank you. And now, without further delay, it's a pizza time. Oh yes. Sorry guys. Can we have a joint photo? Стар нет. Там можно цвет включить? Здесь лучше. Нет, там нет цвета. Там нет цвета. Нет цвета. Все, лучше здесь, снизу, а вы сверху на фотке, да? So, guys, можно где-то здесь. Здесь тоже светло. Просто надо сверху, чтобы было, потому что фотограф сверху.
Здесь тоже, кстати,
Нормально? На стул станет. Окей. Okay, guys. So let's have a picture of all of us. Okay.
Outside the winter.
Outside. So just don't jump at pizza first. First jump.
Okay, thank you guys who is online. Bye bye. You don't have pizza. Thank you, everyone.
ham o'zini tanlaganmiz o'zi. O'zi Aziya Alliansi Bank tanlamoqchi edi.